Hello.
Hello, am I audible? Good morning.
Good morning, sir. Sir,
Yes, yes.
sir,
Morning. Good morning, sir.
can I
Good
say
morning.
something?
Say, please.
Sir, I have actually came to college today for some official work. Principal sir and OSD sir have called me. So I am doing the class from the college only. In case if sir calls me, then I need to go offline maybe for some time. So would you allow me that?
Fine. No issues, sort of. No issues.
I am doing the class, but in
No issues.
case if sir calls me in between the class, then I may need to go
Okay,
offline
fine,
for some
fine,
time.
fine. No problem, sir. Continue.
Thank you, sir.
Yeah.
Then I may need
So I guess the screen is visible. Let's start. Acha, last time we had few topics that I told you that I'll be discussing later. The first topic, as per my knowledge, was removal of null productions. Right, Devarti? Null productions. There is remaining.
Sir. Yes, sir.
So let us do that part, because there are two parts. As per my knowledge, there are two parts still remaining. One is proper explanation of GNS, Grayback normal form. That is somewhat complicated from the last class. So I'll be continuing that one later, not right now, because I want to prepare a hand note for that particular GNS question. And except that, this part I'm discussing now, the removal of null productions. First of all, how we will identify whether a given production is null production. So what is the form of null production? Whenever we have a form like, suppose A gives, this is cap, that is basically A gives epsilon or cap. This is the representation of a null production. And over here, A will be called a nullable variable. So I'm using two terms. One is null production. So a production of the form A gives epsilon or cap. This is the production that would lead into no production of any, or this will not allow any derivation to continue. If we apply this one, no derivation is possible if we have a kind of production which gives A gives epsilon or A gives cap. Okay, so these productions are called null productions. And the variable in this production, over here variable means capital letters, capital A is called a nullable variable. Suppose we have been given a grammar such as this, whose productions are S gives small a capital S or capital AB, where A gives null, B gives null. So I'm using null because it could either be, in this particular case, we have this cap, hat or caret symbol to represent null. And in the CK book, we have epsilon. That is epsilon, epsilon that is used for representing null. This is epsilon. This is used for representing null in CK book. So let me call it null. So A gives null, B gives null, and D gives small b. So out of this, as we can see, A gives null and B gives null. People are wanting to join now also. A gives null, B gives null. So these are straight away null productions. So we have to remove these productions because in the substitution process, these productions will not be utilized. Whenever we are deriving any string, we won't be able to apply that particular production, null production, for my simplification process. Okay. So and another thing is that we know the context-free grammar is monotonically increasing. Now, what does that mean? Suppose we have a production. On application of it, whenever we are trying to substitute that production to derive our string or to generate a parts tree, you know the parts tree or derivation tree. Either we have two different approaches. One is the derivation approach, other is the recursive inference approach. So based on these two approaches, whenever we apply any particular derivation, the string gets monotonically increasing. What does that mean? That on the right hand side, since the format is capital A gives V union sigma whole star, that means zero or more occurrence of that particular variable, or your combination of terminus. Non-terminus is capital letters, but that is variables also, and terminus is small letters. So on the right hand side, we have V union sigma whole bracket star. So that shows that on the right hand side, whenever we apply a particular production rule, the string would go on enhancing. There will be the length of the length or the size of the string will go on enhancing. But imagine if we apply a null production there, so our string will not enhance. Our string will not enhance. So the main logic is that these null productions should not be a part of the context free grammar. But there is an exception. When will it be a part of it? Suppose we have a particular language of the form, say, where the first string has to be null. If you remember, suppose 0 star. Now 0 star, we know the first string has to be a null, epsilon, then 0, 0, 0. So if your null is a part of the string, that means it is a valid string. Only in that scenario, we will be incorporating that production. That means basically S gives epsilon. Only as a rule in the production set, but we will not use in the derivation process. Because when we use the derivation process, the string size gets reduced. And that is not the meaning of monotonically increasing grammar. CFG is a monotonically increasing grammar. Fine. So these null productions should be removed, and only in exceptional cases where epsilon forms the part of the valid string, we would be just keeping that production rule as a part in the production set, capital P. But that will not be used in the substitution or derivation process. Now let's see, suppose we have this given grammar. So your first step would be to construct the set W, and this W would combine or is composed of all the nullable variables. Nullable variables is what? The variables that would lead ultimately into null. So straight away we have A gives null and B gives null as nullable variables. So A and B are nullable variables. So what we'll do first, W1. So we are following the first step, W1, where A1 belongs to Vn. So A1 should belong to Vn. This is a representation. Over here we have to see which are the productions that will lead directly into null. Where A1 gives, this would be null, not A. This would be null. This would be null. Okay? A1 gives null is a production in G. I'm repeating, this is null. So I think I've understood now what I'm saying. This would be null, not A. A1 gives null is a production in G. So we have to use all those variables or all those non-terminals that is directly leading me into null state as the elements of W1. So A and B, because A and B directly gives me null, so A and B forms as the elements of the set W1. Similarly, next we'll do W2, where W2 would be composed of W1 union S. Why we are bringing in S now? Because see, from S we have AB. Now if we apply null over here, we'll have S gives null. We'll have S gives null. So what is basically happening? That this A, B and S together can be said to be those nullable variables which will ultimately lead me into null state. A gives null and B gives null are straight away into null. But when we use, suppose this production, S gives AB. Now when we apply null over here, it will be S gives null. Indirectly it would mean S gives null. I'm allowing. Okay. So look, see. So AB was there from W1 state, and we are doing a union operation with S. Why S? Because S gives AB as a production, and AB ultimately would result in null state. So now we have S, A and B as part of W2. Now when we go for W3, so whatever set we had from W2, and do we have any other particular productions that would give me null? See, now we have S gives AS. Now S gives AS will not give me null. S gives AS will not give me null. So this is the state where we will not hunt more. And now since W3 has become equal to W2, we will stop at this stage, and whatever value we have got in W2, that is the set of nullable variables. So S, A and B are treated as or are declared as nullable variables. Next up, we will be seeing that once the nullable set is being formed, nullable variable set, we have to modify our given production set. So if it is capital P, we have to form P star or P dash. So see which productions are there. S gives AS or AB, A gives null, B gives null, D gives AB. So A gives null, B gives null is straight away rejected, removed from there. But let's see for the others. Now D gives B is included in P dash. Why? Because there is no issue with the nullability here. Next up, S gives AS. Now from S gives AS, imagine if we would have used AB here, like we had AS, if we would have used AB in the next stage, suppose S gives AS was the first production rule that we have applied, next we are applying AB by substituting S gives AB. And we know A and B are both giving null. So what we need to do, we need to bifurcate, or we need to represent this S gives AS as two different productions. One would be S gives AS, and if S is kept as null, it would be S gives A. Are you understanding what I'm saying? Since S gives AS is there, in case of S, if we apply AB, and since A and B are leading me ultimately into null state, so we'll be having S gives A. So S gives AS and S gives A would be the new rules compared to the S gives AS in the capital P. Similarly, S gives AB. There was one particular production rule, S gives AB. We knew that there was that A and B will ultimately lead me into null state. But you have to keep in mind that A and B together cannot be substituted. If we apply A gives null, we will be having S gives B. If we apply B gives null, we will be having S gives A. Or if we, so this S gives AB will actually give rise to S gives AB, S gives A, and S gives B. So now these new productions, there is P dash would comprise of a B gives B, S gives AS, S gives AB, S gives A, S gives capital A, S gives capital B. This is the new grammar after removal of null productions. Is it clear what I'm saying? Is it clear? Anybody?
Yes, sir.
Clear? So pakka so? Clear?
Yes, sir.
Okay. So this way we will be doing. So basically your new grammar that is being formed, the language of G1, that would be all that one minus null. So original minus null. So that is where we will be removing the null productions from our grammar. This is one part. Today we will start the new topic, PDA. Push down automata. So right now from my side, I think GNS proper explanation is remaining. Anything else that I told you to keep on hold apart from GNS? Do you remember, or can you tell me? Except GNS, anything that I have like skipped for that time or you didn't understand? So in case if you remember something, kindly inform your CR, or you can inform me also. So do that part. Because from my side, as per my knowledge, Grayback normal form explanation is remaining. We will be doing certain sums and then we'll understand. Achha. Let's start PDA, push down automata. So this is the basic structure of PDA. It comprises an input tape on which the input string has to be placed. This is the input tape, and we have to fix, or we have to apply an input string on this input tape. There will be a read head which reads the characters in input string one by one. So you can see this is the read head which will be moving. There has to be a movement either towards right side or towards left side. That will be specified by the pointer. But this is the read head which should be at each point of time to be pointing to a particular cell of the input tape. Okay, and that each cell will be comprising some characters or some values of the input string. And then we have a stack or a push down store. This is also called a push down store. It's a stack which is kind of an auxiliary memory. What is an auxiliary memory? Secondary memory, which stays permanent. Okay, so we have these are the main three components of a push down automata. Fine. So basically we can say the PDA is a machine that contains a mechanism to read the input string. It will have a stack to act as memory element, and there will be a set of transition functions to manage the push and pop operation in the stack. Because we know the stack has only two valid operations, push and pop. Like a queue had insert and delete. Similarly, a stack has push and pop. And we will be pushing in the element until unless we reach the maximum level. Right? And the moment if you try to pop out the elements from the stack, and the moment we reach the minimum value, that is almost all the elements are removed, and we attempt to do the pop, we'll have an underflow. And if we attempt a push operation, if the stack is full, we'll have an overflow. Right now, the concepts from data structures, this is the concept. So formally, we can define a PDA as a so it's a 7-tuple structure where we have Q, sigma, this is basically capital gamma. Okay. Then we have delta, Q0, Z0, and S. So these are the 7 tuples of a PDA, push down automator, where Q we know is a set of states, sigma is the character set of the language, basically the input symbols. Now gamma is a set of symbols that can be pushed into the stack. So all those symbols that will be pushed into the stack will be represented by the gamma set. Delta is the set of transition function. Q0 is the starting state of read head. So this read head starting state will be Q0. Z0 is the initial push down symbol. So push down symbol means the symbol that would be pointing by the top of or the pointer. You remember the pointer concept of a stack? So that is represented by Z0, and S is a set of final states. So this is the basic structure of a push down automator, and these are the 7 different tuples that forms the formal definition of a PDA. So now look over here. Suppose we want to prove that PDA accepts the language L equals to 0 to the power n, 1 to the power n, such that n greater than equals to 1. So if we want to prove this using the PDA concept, so what will we put over here? So suppose if we take n as 3, so we'll be having 3 zeros and 3 ones. So that would be kept in the input tape 0, 0, 0, 1, 1, 1. This is just for a sample demonstration where we have taken n equal to 3. Okay, so there will be a read head initially pointing at Q0. There is a push down store. Initially it had Z0. This is the push down symbol. Okay. Now the instantaneous state of a PDA is defined by 3 parameters. So at any point of time, whenever we want to see at what particular state the PDA is in, it will be represented by 3 parameters. It is Qi, W, and alpha, where Qi is the current state of read head. So Qi would be the current state of the read head. So initially Q0, later it would be like Q1, Q2, Q3, depending upon what state we are in. The states are represented by circles, if you remember the transition graph. W is the part of string yet to be processed. Suppose in the beginning it would be 0, 0, 0, 1, 1, 1. So Q0 would be the first parameter in the beginning. W would be having 0, 0, 0, 1, 1, 1, the full string. And after each processing, we will be reducing the string. And alpha would be the current content of push down store. So initially it would be Z0. So look at this. Suppose we have to find out the transitions. So delta of Q0, 0, 0, 0, 1, 1, 1 is the original string, and Z0 is the current content of push down store, the initial symbol. Is it clear? This part? So we represent the instantaneous state of a push down automaton by 3 parameters: current state of read head, the string that has to be processed, and the present content of the push down store or the stack. Fine. So in the beginning, this will be the configuration. Q0 read head state, the initial state, original string on the input tape 0, 0, 0, 1, 1, and Z0 the initial push down store symbol or stack symbol. After processing, so now see we are at Q0. If we process 0, do we get to move the state? Suppose we are having Q1 now. If I process 0, if I am suppose at state Q0, and if I process 0, so the one particular symbol would be removed from the original string because that 0 has been processed. Okay, and since we are moving from one state to different state, we are naming it suppose Q1. Understand what I'm doing? Suppose I am at, okay, let me just represent using a diagram. I am saying, suppose I am at Q0. What does it say? That I am at Q0. Now, when I consume, either I can consume 1 or I can consume 0. So what is it showing? That Q0, 0. So Q0, when consuming 0, will lead me into a new state. Suppose I'm naming it Q1. Is it clear? So we are in a new state Q1. Okay. So, and since this symbol has been processed, that symbol will now form the part of the push down store. So that 0 would be kept in the push down store. It becomes 0, Z0. So we had Z0. Now 0 has been pushed inside. Is it clear? Is it clear what you say? See, from this particular state to this particular state or transition, we were at Q0. We are processing the first 0. On processing, the state should change. The state, suppose we are naming it Q1. And because one particular character or symbol has been already processed, so now we have 0 0 1 1 1 because first 0 has been processed. And where will this 0 go after processing? It will be pushed inside the push down store. So that Z0 which was now now we could see that 0 has been pushed inside, so it is 0 now. So it is 0 Z0. If we read top to down, it will be 0 Z0. Is it clear? First to second.
Yes, sir.
Yeah.
Yes,
now
sir.
after this, suppose we are at Q1. We are at Q1. Now if we have 0, so we can change a different state or we can keep the same state also. Over here, more than the name of the state change, because what is important is what is happening at the side of the push down store. Our objective is to, when do we say that we have a particular string's acceptance when we reach the final state. That's why we have the concept of capital F. Okay, so we will be doing this particular process until unless we have the entire string processed. So next, what will happen? See over here. Suppose we are at Q1, we process 0, so that 0 would be pushed inside the stack. This way again, Q1 0 pushed inside stack. Now after this, suppose now since already we have seen what Q1 0 we have done, we are not moving the state, changing the state. That's why now when Q1 is given 1, we have to change the state. We have to change the state when Q1 is given 1. I could have changed the state here also. But see, imagine we are at a state Q1 and we are applying 0 to it. If we are at a state Q1, we are applying 0 to it. Will a state change? Generally, we are at Q1, we are a particular state and we apply 0. So 0 is not taken as an input now, as such. That's why we are in the same state. But when we are saying 1, explicitly I am giving a high input. 1 is considered to be high input now. So that moment there should be a state change. So Q1 will now become Q2. So it will be Q2 1 1 1 0 0 Z0. Is it clear what I'm saying? Is it clear? So first is so basically see, if we try to formulate that particular thing using the transition functions rules, so it will look like this. So firstly we have del, so Q0 0 0 0 1 1 1 Z0. Okay, and that would give me what? Del of Q1 5 0 0 1 1 0 Z0. That was the first condition. And which function we have used? We have used this function. That if Q0 will have 0 as input and Z0 would be the initial or you can say the push down store's content, then that would give me Q1 0 Z0. That only we have used, because if we use this transition function, only this transition is allowed. So this is the transition function used and this is the transition that has taken place. Is the first statement clear? Is the first row clear? See, this symbol is used to represent transition. This symbol is used to represent transition. It's basically like you can say the inclined T. If you see properly, it is inclined capital letter T. This symbol represents transition. Because of this transition function, we have been able to move from this del Q0 0 0 0 1 1 Z0 to del Q1 0 0 1 1 0 Z0. Is it clear? Shall we proceed? Now look at the second one. So whatever value we had, that would be the input to the second one. And after this we will have del of Q1. Again 1 0 will be used. So for this, we have used this transition function. Del of Q1 0 0. We will not write Z0 here, because that is not a transition function. We are using a transition function. This Z0, why we are writing Z0 here? Because it is the starting state transition function. But after this, we will be using which transition function we have employed for doing the transition. While doing the transition, we have to represent or we have to encode all the symbols of the push down store or stack. But during transition representation, we will be using only each transition. Like suppose if we are at Q1, if 0 is given as input, then what will be the produce or what will be the value that has to be put inside the stack? It should be 0. So Q1 0 0 will be transited into Q1 0 0. Am I clear what I'm saying? Is it understandable what I'm saying?
Yes, sir.
So what does it say? What does it It means what? When suppose the read state is pointing at state Q1, the read head is pointing at state Q1, and when 0 is encountered as the input symbol with 0 on top of stack also. Okay, so we have 0 on top of stack, we have 0 on the input tape as an input symbol. So the input symbol 0 has to be put onto the stack. So we have to put the input symbol 0 also onto the stack. Now look at this. So first let us see all the transition functions. Now let's see, this is repeated. Let's see here. Suppose Q1, 1, 0. Okay, so 1 is on the input tape, 0 is on the push down store or stack. So if this is the delta transition that has to be employed, then what will be the resultant? It will be Q2, epsilon. What are you trying to do? It indicates that when the read head is at state Q1 and when it encounters the 1 as the input symbol with 0 on top of the stack, the symbol 0 is popped from the stack. When I say Q2, epsilon, that 0 has to be popped out from the stack. Suppose we have to count equal number of zeros and ones. So we have 000, 111. Okay. We have 000, 111. So at the time of 00, we are pushing 000 onto the stack. And the moment 1 is encountered, we are popping out 0. So in the end, if we have the final state, we can say that string has been accepted. Right or not? Suppose we are having a mechanism where we want to see whether the given string has equal number of zeros and ones or not. So if I suppose at the time of inputs, at the time of checking zeros, if we whenever a 0 is encountered input tape, we are pushing in 0 onto the stack. And the moment 1 is encountered, we are popping out 0 from the stack. So if zeros and ones are equal, at the end we will be having only initial state. So that's 0 na? Onto the stack. So basically the stack will be empty at the end. Yes or no? Are you understand
Yes,
what I'm saying? Yeah. So what does it indicate? That the number of zeros and ones will be equal. Whenever 0 is encountered, we are pushing onto the stack, and whenever 1 is encountered, we are popping out 1 0 from the stack. So for each 1 0 will be popped out. So if this is the process, after process of all the zeros and ones, in the end the stack should be empty though. So empty stack would indicate that the whole string has been successfully processed and all the zeros have been equated with all ones. That shows the equal number of zeros and ones. Because if in the end we have extra 0 in the stack, that shows that 1 0 was extra, or we have unequal number of zeros and ones. That is the logic. So we are using these transitions, and this transition means that the moment 1 is encountered on the input stack and there was a 0 on the 1 is encountered on the input tape, middle is on the input tape, third one is on the stack, and 0 is on the stack. At that moment we will be popping out that 0. This epsilon indicates popping out of that 0. Similarly, the same thing, and yeah, that's it. Now let's see. So initial part we have done. Second is Q1. So Q1 00111 will become Q1 011 00Z0 because that was the logic. That was the transition that we have employed. Whenever we are at state Q1, 0 is on the input tape and 0 is also on the stack, the transition would be Q100. So now the stack will have 00. So it is having 00. Next up, again the same thing. The stack will have again 00. So it is now Q1 111 000Z0. Next up, now when Q1 and 1 is encountered and on stack we have 0, so we are popping out 10. So it will become Q2 1100Z0. See, 10 has been popped out. Similarly, again the same transition function. So Q2 1100Z0 will give Q2, this double 1 will become single 1, and this double 0, again 10 has been popped out, it is 0Z0. Next, Q2 10Z0, so we'll now have Q2. Since 1 has been processed, it will be epsilon, and this 0 is removed, so it will become Z0. So what do we have in the end? In the end, we have Q2 epsilon Z0. That should give me Q3 epsilon. So why is epsilon? Why are we doing this particular stage? And for doing this stage, we are using the production state function, which is delta of Q3 epsilon Z0. If there is no string left on the input tape, and if there is only the initial symbol on the stack, that would be transited into Q3 cell. In fact, that Z0 initial symbol that we have explicitly put inside the stack in the beginning, that will also be removed or popped out, leading me into a new state. There's a new state with nothing on the input tape, nothing on the stack. This shows what? That we have equal number of zeros and ones over here. Okay? Got my point? Yes? Yes?
স্যার বলছি লাস্টে যে Z0টা বললেন ওটা কি সবসময় আমাদের স্ট্যাক থেকে রিমুভ করে দিতে হবে না ওটা স্ট্যাকে
না ওটা স্টার্টিং এ রাখতে হবে কেন কি Z0 দেখো বলেছিলাম না Z0 ইজ দ্য ইনিশিয়াল স্ট্যাক সিম্বল Z0
ওটা স্টার্টিং এ রইলো এবার আফটার আমরা এই প্রসেসিংটা করে নিলাম তারপর যখন দেখাবো তখন কি এমটি স্ট্যাকই দেখাতে হবে না লাস্টে Z0 শুধু পড়ে থাকছে ওই স্ট্যাকটা দেখালো
Z0 তো আমরা ঢুকিয়েছিলাম আর Z0 আমি যদি স্ট্যাকে ঢোকাই স্ট্যাকটাকে এমটি বলতে পারি
না বলতে পারি না
তাহলে সরাতে হবে কারণ কি এটা তো আমরা if you remember in data structure also there is a concept of stack evaluation postfix evaluation মনে আছে
মনে আছে
বা যেখানে আমরা যখন করতাম ইনফিক্স টু পোস্টফিক্স করতাম সেখানে আমরা ব্র্যাকেটটা ইউজ করতাম মানে একটা দিতাম আমরা এক্সট্রা ব্র্যাকেট আর যতক্ষণ না ওই এন্ডিং ব্র্যাকেটটা আসছে আমরা করতে যেতাম লাস্টে ওই এন্ডিং ব্র্যাকেটটা রিমুভ করতাম তখন আমি বলতাম কি স্ট্যাক ইজ এমটি বা আমাদের পুরো প্রসেসিংটা হয়ে গেছে সেম প্রসেস এখানে বিকজ দ্য Z0 হ্যাজ বিন মানে ইনপুটেড বাই আস যতক্ষণ রিমুভ করব আমরা ওটাকে স্ট্যাককে এমটি বলতে পারি না ঠিক আছে তার জন্য এই এক্সট্রা স্টেপটা করলাম আর এক্সট্রা স্টেপটা করার জন্যই তো আমরা একটা এক্সট্রা ট্রানজিশন মেথড লিখতে হলো সো মোট এখানে কতগুলো ফাংশন থাকলো একটা থাকলো Q00Z0 ওয়ালা এইটা একটা সিঙ্গেল 1 এটা 2 নম্বর এটা 3 নম্বর
হ্যাঁ আর 4 নম্বর
চারটে তো এই চার so this particular PD that we have designed has 4 different transition functions and we are using these transition functions based upon our requirement to process the string on the input tape using the stack as the memory element. Got my point? And
yes.
what we have tried to attempt? The acceptance of the string 000111. So this is one way of accepting the string, where the stack's emptiness, or when we are claiming that the stack has been successfully, like all the elements of the stack has been cleared or popped out, that indicates that the string has been successfully processed. Now, when the closing state was reached, তখন আমরা বলছিলাম কি string has been accepted. But while using stack, this is another technique that has been added, that whenever the string that was on the input tape, while processing, we are pushing in some elements in the stack also, and at the end, after all the transition functions are applied, all the transitions are over, if at the end they have the stack which is empty in nature, then we can also declare that the string has been successfully accepted by the PD. Okay? Achha. Let's see next question. So you can see over here, the total definition of PD will now become, so we had 7 tuples. So Q has Q0, Q1, Q2, Q3. Sigma has 0 and 1. Initial state was Q0 only. This is the Z0 is the initial push down symbol. F is empty in this case as the string is accepted by null store. So we are using the concept of acceptance by null store. Null means empty. Store means push down store or stack. So over here, this capital F is indicating. So there are 2 ways. One is by closing state, by reaching the closing state. Second one is by reaching a null store kind of set configuration. Null store means empty stack. Null store means empty stack. So over here, this F is representing empty stack. And this gamma, what was the meaning of gamma? What was the meaning of gamma? Gamma meant, what did gamma contain? The set of symbols to be put inside the stack. Right? So stack এর মধ্যে Z0 put করছি 0 put করছি আর তো কিছু put করছি না stack এ কেন কি the moment 1 is encountered আমরা 0টা remove করছি এই জন্য গামার মধ্যে খালি 0 Z0 আর ট্রানজিশন ফাংশনটা কি থাকলো দেখে নাও 5টা হলো এখানে 5টা থাকলো 4টে বলছিলাম 5টা হলো না একটা Q1110 ছিল আর Q2110 ছিল আচ্ছা এখানে মিস করেছে নাকি আমরা এই দেখো এইটা আমরা কাউন্ট করব
না ওটা আমি ট্রানজিশন স্টেট বললাম 4টে 0 1 2 3 আর ট্রানজিশন ফাংশন কি ছিল
ট্রানজিশন মানে 5টা আছে পাঁচটা আছে না? এই দেখো না, Q000 একটা, Q000 একটা, Q100 এক, না এটা Q110 একটা, Q210 একটা, এখানে চারটে হলো, আর এইটা লাস্ট একটা, পাঁচটা। So these are the 5 different transition functions. So মানে আমরা এটা কি করলাম, we have seen the formal definition of the PDA where we have defined all the transition functions and we have defined all the 7 different tuples. Q, sigma, Q0. This is basically the designing part. Now suppose if a question comes, design a PDA M1 to accept the string L2 equals to A to the power N, B, A to the power N such that N greater than equals to 1. Bolo, how to do it? What should be our approach? Tell me. নিচে solve করা আছে, তুমি বলো কিভাবে করব? How should we approach this particular thing? First, we have to emphasize what will be the read head initial value or initial symbol, that is Q0, push down initial value, that is Z0. All these things we have to specify now. Acha, from here, suppose we have to take a string. Tell me any string from here which you want to take.
Sir, double A, B, double A.
Suppose double A, B, double A. Acha. এখানে ট্রিপল এ নিয়ে করছিল, তারপরে মনে হয় ডাবল, আচ্ছা ট্রিপল এ, এখানে ট্রিপল এ নিয়ে করা আছে। আচ্ছা, এটা আমি এক্সপ্লেন করি, তারপরে হয়তো তোমরাও মানে সি রাইট নাও হোয়াট ইজ মোস্ট ইম্পর্টেন্ট, আই টোল্ড ইউ প্রিভিয়াসলি অলসো, ক্যাপিটাল পি or delta, because capital means production set, delta means transition function, same thing. Okay, so these are very important while defining formally the tuple, the 7 tuples of any machine, may it be PDA, may it be your Turing machine, may it be finite automata, whatever it is. So see, suppose we are taking n as 3, so we are having this structure AAA, B AAA, correct? So
Yes, sir.
our initial value is Q0, initial state of the read head, and initial symbol pushed inside the stack is Z0. This first one I think fine, no issues with that. So this is the instantaneous description of the PDA at the very beginning, the initial level. What I'm calling instantaneous description, ID. ID of a PDA is represented by 3 parameters: the current head of the, or you can say the current read head, or the current symbol of the read head. Second one is the string that has to be processed on the input tape, and the current symbols on the stack or the push down store. So these are the 3 parameters. Okay, Q1, W, that is W is the string, and alpha. Alpha is the set of symbols on the push down store. So for the first one, see which transition we use, similar to the previous one only. So Q0, when A is encountered on the input tape and Z0 is encountered on the stack, your transition should be new state, that is Q1, A Z0. So you can see it is Q1, 1A has been removed from here, and that A has been put inside the stack. I'm repeating, this is the state, input tapes, current configuration, stacks, current configuration, current read head, current input tapes configuration, current push down store or push down or stacks configuration. Fine. Next up, again this, now we have Q1A. So it has to be Q1AA. First symbol of this one, first symbol of this, it's Q1AA. It will give me Q1AA. That means, so it should be coming into Q1. 1A has been already processed, so it is now AB AAA, and it has become AA Z0. Is it clear?
Yes, sir.
Yeah. Next up, again the same thing. This is repeated. These two are repeated. Now suppose the chance comes for B. So when B is encountered, so Q1BA, it is Q1B and this A. What is happening? It is, what are we doing?
স্যার এটাকে রেখে দেবো খালি, আর ডিটা রাখবো না স্ট্যাকে।
এটাকে রেখে দেবো মানে যদি এ থাকে, সেই
এ থাকে আর ডি পায়, তাহলে ডিটাকে আর রাখবো না, শুধু সিঙ্গেল এটাকে রেখে দেবো।
মানে যে এইটা
যেটা ছিল সেটাই থাকবে।
মানে ওই বেসিক্যালি আমরা বি এর জায়গায় কোনো ইনক্লুশন করলাম না, তার মানে এটা হয়, বুঝতে পারলে? যেমন এখানে যখন এটা ছিল, এর জায়গায় ডাবল এ, মানে ওই এটা প্রসেস করার জন্য সঙ্গে সঙ্গে ডাবল এ হয়ে গেল, বাট এখানে বি আসা মানে since the B has been processed, still there is no change on the push down store. A ছিল এই আছে, ঠিক আছে? তাহলে দেখো এখানে কি হলো, so a B has been removed but this triple A Z0 is same, so no movement in the on the push down store side. Next, এখন Q2AA, তার জন্য আবার নিউ ট্রানজিশন, সেখানে আমি কি করছি, আমি রিমুভ করছি। Now the process of removal of one by one the symbols from push down store has started. So see, triple A Z0 ছিল, এখানে double A হয়ে গেল, মানে একটা প্রসেস করে this is also removed from here. Similarly আবার এই সেম জিনিসটা এখানে করলাম, so Q2AA it will become Q2A Z0, one A is removed, one A is removed. Next up again Q2AA, so again this, now it has become the input tape has become empty, and over here we have Z0. So finally Q2 epsilon Z0 will give me Q3 epsilon, a new state with all the values empty in the push down store. So it is now Q3 epsilon epsilon. So this one is an extra state to just remove the extra initial symbol in the push down store. That's why we have used this particular transition function. So what is the definition of PDA now? So Q is Q0 1 2 3, sigma is AB, gamma is AZ0, the symbols that were included in the push down store, and delta is given by these 5, or I think 5, no? 5, so I guess 5, similar to previous one. So they see Q1 A001, Q1 AA2, Q1 BA3, Q2 AA4, and this one Q2 epsilon Z05. So there are 5 transition functions. Is it clear? Is it clear?
Yes, sir. Yes, sir.
So basically what was the question here? We had to design a PDA to accept the language this one. So as we can see, A to the power N and A to the power N, these were common, and these basically acting as a separator, right? So for that B we have not made a change, but what we have seen is that equal number of A's were put inside the store, and when again equal number of A's were processed on the input tape, each time for an occurrence of A, one value was being popped out from stack. In the end the stack would become empty. That would show the acceptance of the string by the PDA, and therefore we have formally defined the 7 tuple structure of PDA. So okay, let's see, some homework is given over here. Achha, write one homework. So design a PDA capital M to accept the language L. Design a PDA capital L to accept the language L equals to A to the power N, B to the power 2N, A to the power N, B to the power 2N, such that N greater than equals to 1. A to the power N, B to the power 2N, such that N greater than equals to 1. So we have to design the PDA. So while designing, we have to specify the 7 formal tuple structures. Okay. So what do we see over here? What do we see as per the question? That
একটা এ থাকলে দুটো বি থাকবে এরকম।
আচ্ছা, তাহলে আমাদের পুশ ডাউন স্টোর স্ট্যাকে যে কনসেপ্টটা তাহলে কি থাকবে? আমরা প্রথমে তো এইগুলোকে পুশ ডাউন করব স্ট্যাকের মধ্যে।
ওই একটা এর জায়গায় আমরা দুটো করে এ পুশ করব, তাহলে ওই বিটা যখন রিমুভ করব পেয়ে যাব।
না এটা কি করে হবে?
মানে
পুশ তো আমরা একটা এই করতে পারি না, একটাই তো। সাপোজ আমি যদি এটা ইনপুট সিম্বল একটা স্যাম্পল স্ট্রিং নিই, সাপোজ ট্রিপল এ, তাহলে 6টা বি আসবে।
হ্যাঁ,
যখন আমি ট্রিপল এ 3টে এ তো পুশ করতে পারি ম্যাক্সিমাম। মানে কি হবে তাহলে? চেঞ্জ কোথায় হবে? when we will be popping out one A, at that moment 2 B's has to be processed, but 2 B has to be removed. বুঝতে পারছো কি বলছি? মানে when first A, so when A, we will be pushing in A inside the stack, but while popping out 2 B's will be popped out. মানে while popping out one A, 2 B's will be, but the read head will be moving towards after 2 B, that way.
স্যার ওটা মানে লিখবো কি করে? মানে ট্রানজিশন স্টেটটা তাহলে কিভাবে লিখবো?
ট্রানজিশন স্টেটটা কিভাবে লিখবে? প্রসেসিং জন্য?
হ্যাঁ। মানে ওই একটা মানে বি কে দেখলাম একটা বি পেলাম আর ওদিকে স্ট্যাকে একটা এ পেলাম, তারপরে ওটা মানে ট্রানজিশন করে ওই পাশে ওখানে তাহলে কিরকম করে
তোমার স্টার্টিংটা তো এটা ওটা তো ইজি হয়ে যাবে। প্রথমে তো তুমি সাপোজ তুমি করলে ডেল্টা, ফার্স্ট এটা কি আছে Q0,
হ্যাঁ
এখানে কি থাকবে
এ
সাপোজ সাপোজ এ এ আর চারটে বি করলাম,
চারটে বি, হ্যাঁ হ্যাঁ
চারটে বি থাকলো, চারটে বি থাকলো আর কমা দিয়ে এখানে Z0, এটা ইনিশিয়ালটা। তারপরে এইটা দিস উইল গিভ মি হোয়াট, এটা কি আসা উচিত?
হ্যাঁ এবার হচ্ছে ট্রানজিশন স্টেট আমি Q0 এ আর Z0 দেখতে পাবো। Q0 এ
তো বেসিক্যালি আমরা এই Q0 তে আছি, এ প্রসেস করছি আর এখানে Z0 আছে, তো তার জন্য তো এরকম থাকবে একটা ট্রানজিশন ফাংশনটা Q0 এখানে এ এখানে Z0 আর ট্রানজিশনটা কি দেবে
Q0 মানে Q1 Z0, হ্যাঁ
Z0, right? Z0 will come, so over here কি এখানে কি হয়ে যাবে Q1
A,
হ্যাঁ Q1 the A চারটে
B হ্যাঁ Z0
right, Z0. Then next what will be transition function?
Next হচ্ছে Q1
A
হ্যাঁ আর A, হ্যাঁ
Q1 A
হ্যাঁ
so তখন কি হবে delta of Q1 A,
তাহলে হচ্ছে Q1
double A,
হ্যাঁ
Q1 double A মানে এখানে যখন Q1 A হবে Q1 A,
হ্যাঁ তখন হবে Q1 double A,
it will be give me Q1 double A, right? তো বুঝতে পারছো?
হ্যাঁ বুঝতে পারছি।
এটা তো হয়ে গেল, এটা তো হ্যাঁ এটা ঠিক আছে, এই পার্টটা এই দুটো হয়ে গেল, তো এটা চললো। তারপরে কি আসবে
B মানে Q1 B
Q1 B A Q1 B A
এখানে ওটা কি
এক মিনিট আমি একটু নিউ পেজ করি তাহলে। Q1 B A এটা থাকবে তো,
হ্যাঁ
এটা যখন থাকবে it will give me Q2 A Q1 B A will give me Q2 A।
আচ্ছা তারপরে আবার Q1 B A পাবো,
Q1
তারপরে আবার একটা
Q2
হ্যাঁ আবার Q2 B A পাবো আবার একটা,
তাহলে ডেল্টা অফ Q2 B A
হ্যাঁ
will give Q3 epsilon।
আচ্ছা
তারপরে কি পাবো? তারপরে পাবো আমরা
Q3 তে চলে গেছি,
Q3 B পাবো,
হ্যাঁ
B A পাবো, সেখান থেকে আমরা পাবো Q2 A।
আচ্ছা মানে আবার ঘুরে চলে আসবো ওদিকে,
হ্যাঁ ওটার মধ্যে মুভমেন্ট হবে, কিন্তু কেন কি দুবার মুভমেন্ট করতে হবে না, একটা এর জন্য দুবার বি মুভমেন্ট করতে হবে, আর লাস্টে একটা থাকলো, তাহলে কি থাকলো লাস্টে Q3 epsilon Z0 যেটা লাস্টে,
হ্যাঁ epsilon Z0 তাহলে epsilon হয়ে যাবে
Q4 epsilon, একটা নতুন স্টেট হলো, ঠিক আছে?
হ্যাঁ ঠিক আছে, ওইটা ঘুরে চলে আসবে, ঠিক আছে।
তো বেসিক্যালি PDA টা অসিলেট করছে বিটুইন টু স্টেট টিল যতক্ষণ না মানে সবকটা এ রিমুভ হচ্ছে স্ট্যাক থেকে।
আচ্ছা
তোমরা এটা শো করতে হবে, ইউ হ্যাভ টু ক্রিয়েট এ টেবল যেখানে ফার্স্ট কলামটা হবে ট্রানজিশন, সেকেন্ড কলামটা হবে ট্রানজিশন ফাংশন ইউজড, যেটা এখানে ছিল দেখাতে হবে, ঠিক আছে? এটা দেখাতে হবে ট্রানজিশন ফাংশন ইউজ, যেখানে সব স্টেটস চেঞ্জ গুলো আর এখানে ফাংশন ইউজ ছিল দেখাতে হবে, আর ইন দি এন্ড এইটা ডিফাইন করতে হবে সাতটা স্ট্রাকচার।
ওকে
নেক্সট আপ নাও, সো देयर আর টু টাইপস অফ অ্যাকসেপ্টেন্স অফ PDA। আমি বলছিলাম না কি আমরা তো ওখানে দেখলাম কি we were accepting by the null store concept, that means when the stack becomes empty, right? আর সেকেন্ডটা বলছিলাম যেটা আমরা অলরেডি আগে থেকে করছিলাম, অলদো রিপ্রেজেন্টেশন এরকম ছিল না, বাট কনসেপ্ট ছিল ফাইনাল স্টেট আমরা রিচ করেছি। সো উই ক্যান সে a PDA can be designed to accept two different a PDA can be designed to accept a string in two different ways. One is acceptance by null store, যেখানে কি করছি del of Q0, WZ0 যদি এটা স্টার্টিং স্টেট থাকতো তখন আমরা, আর ওইটা মানে কি হয়, what is the meaning of this symbol? Clean
closure
এই তো না
এইটা কোনটা স্যার?
এইটা এই সিম্বল এইটা মানে এইটা বলছে ট্রানজিটিভ অ্যাপ্লিকেশন অফ প্রোডাকশন। We will be going on applying production. In the end, we'll be having this. মানে in between will be having multiple productions. ঠিক আছে, এটা হচ্ছে মানে ফার্স্ট, এটা হচ্ছে সোর্স এর ডেস্টিনেশন সাপোজ, আর এটা ইন্ডিকেট করছে মাঝখানে আমরা অনেকগুলো ডেরিভেশনস গুলো করেছি। We have applied many productions. That's why it's called transitive application of productions. Got it? This symbol, মানে এই implied symbol as well as the asterisk, this is known as transitive application of productions. So in the end, we will be having this. So if we are having the concept of acceptance by null store, so from this initial state, after applying all the productions, we should reach a state suppose as Q1, epsilon epsilon, that is null null, null on the input tape, null on the stack. That indicates that we have our string has been accepted. Correct? যেটা আমরা করছিলাম, এটা আগে করছিলাম তো।
হ্যাঁ স্যার, এটাই করছিলাম।
আর সেকেন্ডারি ক্ষেত্রে কি হচ্ছে, Q0 W যেটা শুরু করলাম, after transitive applications we will reach QS sigma alpha, মানে there can be some values on the push down store, there can be some values on the stack, but we have reached the final state. Over here QF is a state, or QF is an element, state of the belonging to F, or element belonging to capital F. It is the final state. Alpha belongs to gamma star, alpha belongs to gamma star, gamma mane the symbols on the stack that I use করলাম। We could have A over here, we could have 0 over here, we could have Z0 also, no issues, but the state at which the read head will be pointing at the end should be QF, and QF is a element of capital F. QF belongs to capital F, that is QF is a closing state. Likewise, Q0 was an initial state, QF is a closing state. Got it? Understood?
ইয়েস স্যার, তার মানে এখানে মানে অ্যাজ এ সিম্বল হিসেবে Z0 টাও থাকতে পারে, তখন সেটাকে আমরা অ্যাকসেপ্টেড বাই ফাইনাল স্টেট বলতে পারি।
হ্যাঁ, ফাইনাল আমাদের এই গোটা কিন্তু স্ট্রিংটা প্রসেস করে নিতে হবে। W has become epsilon, মানে আমরা আমাদের ইনপুট টেপে এমটি, ইনপুট টেপে এলিমেন্ট নেই, কিন্তু ইনপুট টেপে has become empty, বাট প্রসেস করার পরে আমাদের যে রিড হেডটা যেটা লাস্ট স্টেটে পয়েন্ট করছে সেটা কিন্তু ক্লোজিং স্টেট। সেই ক্ষেত্রে আমাদের নাল স্টোর মানে পুশ ডাউন স্টোর মধ্যে কোনো ভ্যালু আছে কিনা সেটা ম্যাটার করে না।
আচ্ছা আচ্ছা,
সো ডিপেন্ডিং আপন দ্য কোশ্চেন, এই দুটো কিন্তু একসঙ্গে হবে না। You can get a question designed by using the concept of null store or designed by using the concept of final state. মানে এই দুটোই পসিবিলিটি আছে। আচ্ছা, আর একটা জিনিস আছে কি, সাপোজ we have a PDA, এদের মধ্যে আমরা ট্রানজিশন করতে পারি, মানে a PDA accepting a context-free language. We know that CFL মানে context-free language এর জন্য we require PDA, এটা তো বলেছি লাস্ট ক্লাস থেকেই বলছি, আগে লাস্ট উইক থেকেই বলছি। যেভাবে রেগুলার ল্যাঙ্গুয়েজটা অ্যাকসেপ্ট করার জন্য we have FA, fine automaton. Similarly for CFL the tool or the machine that is required is PDA, right? So a PDA that accepts a context-free language by final state, মানে যদি সেকেন্ডের কনসেপ্টটা নিয়ে বানাই আমরা, it can be converted to an equivalent PDA accepting that same language by null store. কিভাবে করব? We have to rename QF as QK to remove the tag of final state. প্রথমে we have to remove this particular final state and we will rename it as QK suppose to indicate any other state, not the final state. Second, declare F as empty set. সেক্ষেত্রে আমরা F টাকে empty করে দেব। F is এখানে কি মানে কি আমাদের তো কনসেপ্টই হচ্ছে F এর in case of null storage the stack should be empty, right? And third stage, at the transition function QK epsilon A, suppose we are at state QK, we are having the input tape empty, but there is some value or some symbol on the push down store, that is stack, that would be now QK epsilon. So we have to remove it. What are we trying to achieve from here? This conversion, we are trying to see that if we are having the logic of acceptance by final state and we are converting into acceptance by null store, there is a possibility of doing it. What are we doing? First stage, we are removing the tag of final state from the QF and considering it to be a normal state. Secondly, if we are making capital F as null, that is phi, and at each transition function QK epsilon A, if there is some value on the stack that has to be removed for each transition. Okay, got my point? What I'm saying? Are you understanding? Theoretically, are you understanding? Anyone? Are you understanding theoretically?
স্যার আরেকবার বলবেন স্যার।
আমি বলছি যখন আমরা একটা স্টেটকে কনভার্ট করছি, মানে স্টেট কনভার্ট করছি না, মানে আমি একটা ডিজাইন করেছিলাম ফুশন অটোমেটা, সেখানে দুটো কনসেপ্ট দিয়ে হয়, তো নাল স্টোর অ্যাক্সেসরিজ দিয়ে হয়, ফাইনাল স্টেট দিয়ে হয়। সাপোজ আমাদের যদি ফাইনাল স্টেট দিয়ে করছিলাম, আমাকে বলছে কি আমি ওই ফাইনাল স্টেট যেটা করছিলাম সেটাকে যদি আমাকে কনভার্ট করতে হয় নাল স্টোরে, ওই সেম কনসেপ্টটা করতে হয় নাল স্টোরে, তখন কি করবো? উই নো ফাইনাল স্টেটের মধ্যে কিউ এর জিনিসটা দিয়ে শেষ হবে, তো আমরা যখন ওটাকে এই নাল স্টোর কনভার্সনে নিয়ে আসছি তখন কিউএফ কে কিউ এর মতন ট্রিট করবো। কিউ কে মতলব নন ফাইনাল স্টেট, এটা নর্মাল স্টেট একটা, মানে আমি বেসিক্যালি আর ফাইনাল স্টেটের কনসেপ্টটা আনছি না, সরিয়ে দিচ্ছি। যখনই সরাচ্ছি ক্যাপিটাল এফ টা এমটি করে দিচ্ছি, তো ক্যাপিটাল এফ ইন কেস অফ নাল স্টোর শুড বি এমটি, দ্যাট ইজ দি কনসেপ্ট অফ নাল স্টোর, নাল স্টোর মানে এমটি স্টোর, ঠিক আছে? আর ট্রানজিশন ফাংশন কিভাবে চেঞ্জ হবে? যখনই কিউ কেস আসছে, ইনপুট টেপের মধ্যে এপসাইলন আছে, আর এখানে কোনো ভ্যালু আছে, এখানে এটা কি a belongs to gamma, right? না a can be z0, it can be z0, it could be your what is it called, 0, whatever value we have, that value belongs to the gamma set. যখন এটা হবে ওটাকে রিমুভ করে দিতে হবে, ওটাকে রিমুভ করে দিতে হবে। ঠিক আছে,
ঠিক আছে, হ্যাঁ বুঝতে পেরেছি।
এখন উল্টোটা যদি করতে হয়, নাল স্টোর থেকে ফাইনাল স্টেট, a PD accepting a context-free language L by null store can be converted to an equivalent PDA accepting L by final state as follows. So we have to add a state QF, ওখানে আমরা রিমুভ করছিলাম, এখানে বেসিক্যালি রিনেম করছিলাম by removing the tag of final state, এখানে আমি অ্যাড করছি একটা state QF to the set of states Q, and we will add this QF to capital F. Yes or no? করতে হবে না? মানে আমরা নাল স্টোর কনসেপ্টে ছিলাম, নাও উই আর ট্রাইং টু কনভার্ট ইট ইনটু ফাইনাল স্টেট, সো ফর ডুইং দ্যাট we are incorporating a new state and we are naming it QF, because F means final and that entry has to be done in the capital F also, that we are doing, adding QF to F. Next, and we will change the transition function. Suppose যেটা নরমাল ছিল ডেল্টা অফ QK epsilon Z0, যদি এরকম একটা স্টেট আসে, এরকম একটা যদি ইনস্ট্যান্টেনিয়াস ডেসক্রিপশন হয় ফুশন অটোমেটা, দ্যাট উইড বিকাম QF, epsilon, না মানে যদি এই গোটাটা হয়, দ্যাট এখানে কি ছিল QK epsilon Z0 ছিল না, এখানে QK epsilon A মানে সাপোজ Z0 বা কিছু থাকলো, বুঝতে পারলে কি বলছি? মানে আমাদের কাছে তো আগে এটা ছিল, এটা তো আমরা কনভার্ট করছিলাম ইনটু নাল স্টোর ফরম্যাট, বাট যখন আমি ফাইনাল স্টেটে করব, তো এই ধরনের ট্রানজিশন ফাংশনটা যেখানে QK epsilon Z0 আছে, যেটা দিচ্ছিল প্রথমে QK, epsilon, now it will be transformed into QK epsilon Z0 will give QF Z0, মানে QK টা আমি QF বানিয়ে দিচ্ছি। বুঝতে কি বলছি? মানে এই গোটাকে একসঙ্গে ট্রিট করো, মানে এই ধরনের ট্রানজিশন ফাংশন will now become, মানে লেফট হ্যান্ড সাইডটা সেম আছে, বাট QK টা নাও will be transformed into QF। মানে এটা কি দেখাচ্ছে কি আমাদের নাল স্ট্যাক, মানে আমাদের স্ট্যাকটা কিন্তু ইনিশিয়াল সিম্বল খালি আছে, ঠিক আছে? আমাদের গোটা স্ট্রিংটা প্রসেস হয়ে গেছে, the entire string has been processed, but the final state has not been reached, so we are basically trying to make it a final state. So QK is transformed into QF and Z0 is Z0 only, no issues with that. এটা কি যখনই এই জিনিসটা আসবে তখন আমরা নেক্সট স্টেজে আমরা ওটাকে এমটি করে দিতে পারবো, মানে যেটা আমরা এতক্ষণ আগে এটা করছিলাম, এরপরে আমরা কিন্তু এটা অ্যাপ্লাই করতে পারবো, এরপরে এই জিনিসটা আমরা অ্যাপ্লাই করতে পারবো। তোমার ছিল না দেখো, তোমার এফটি এটা যেখানে Z0 ছিল, এরপরে ওটাকে আমি এক্সটেন্ড করে দেবো লাস্ট স্টেজে, তখন কি থাকবে? তখন এটা হয়ে যাবে এরকম কাইন্ড অফ, এটা সাপোজ del of QF, epsilon, Z0 will become QF, epsilon।
মানে বেসিক্যালি স্যার খালি একটা স্টেট অ্যাড করতে হবে যদি আমি ফাইনাল স্টেটে গিয়ে ওটাকে শেষ করতে চাই, আর যদি নাল স্টোরি করতে চাই তাহলে নতুন করে আর কোনো স্টেট অ্যাড করতে হচ্ছে না, ওই স্টেটেই
উল্টো রিনেম করতে হচ্ছে, মানে যেটা ফাইনাল ছিল সেটাকে আমি নন ফাইনাল বানাচ্ছি, ক্যাপিটাল এফ টা এমটি করছি, আর ট্রানজিশনের মধ্যে কি করছি ওই এইটাকে আমরা সরাচ্ছি, দেখছো ওই জায়গাটা।
ঠিক আছে স্যার, বুঝতে পারছি।
আচ্ছা, না এইটা ওইটা ছিল তোমার করেসপন্ডেন্স বা ইকুইভ্যালেন্স অফ টু ডিফারেন্ট টাইপস, মানে acceptance by null store থেকে ফাইনাল স্টেট and vice versa. Now there is a correspondence between PDA and CFL also. মানে তোমার সাপোজ কন্টেক্সট গ্রামার ফরম্যাটে দেওয়া আছে, তোমাকে পিডিএ তে রিপ্রেজেন্ট করতে হবে and vice versa. তো ফার্স্ট স্টেপে কি করছি আমরা, we are trying to design a PDA corresponding to given CFG. মানে আমাদের কন্টেক্সট গ্রামার, গ্রামারের মধ্যে চারটা টেবল থাকে, V sigma PS, V means set of non-terminals বা ভেরিয়েবলস বলি যেটাকে, সিগমা মিনস সেট অফ টার্মিনালস, ক্যাপিটাল পি ইজ প্রোডাকশন সেট and capital S is starting sentential form. Correct? চারটে ট্যাপল, সেই চারটে ট্যাপল দেওয়া আছে, we have to create 7 ট্যাপলস। গ্রামারে আছে সেটাকে আমি মেশিন পিডিএফ ফরম্যাটে করব রিপ্রেজেন্ট, আর এখানে আমরা ইউজ করছি অ্যাকসেপ্টেন্স বাই নাল স্টোর ফরম্যাট। তো ফার্স্ট রুল কি হবে, লুক এট দ্য রুলস। সাপোজ we have this transition function qi epsilon a, this will be transformed into qi comma alpha, where qi is belonging to capital Q, definitely it will be a part of the capital Q set in some state, and a gives alpha is a production in P. So what have we so what have we done over here? কি শো করছে এটা? What is the first rule saying? Capital that means what, in the grammar capital P there is a production, capital A gives alpha. Are you understanding what I'm saying? In the grammar capital P there has to be a production that means where A will give alpha, only then this transition is possible. মানে A এর জায়গাতে আমি আলফা পুট করব না, তখন কি পুট করতে পারি? This production, this kind of production, যেমন A gives null থাকে, এখানে A gives alpha will be a production in P, তার correspondence হচ্ছে এইটা। সেকেন্ড রুলটা দেখি, সাপোজ we have qi AA, যদি AA থাকে সেখানে এটা কি রিপ্রেজেন্ট করছে টার্মিনাল, তখন কি করব, ওটাকে আমি বাদ দিয়ে দেব, we will remove it. So qi epsilon, where qi belongs to capital Q in some state and A belongs to sigma is a terminal. যখন কোনো টার্মিনাল থাকে, মানে আমরা জানি টার্মিনাল মানে কি হয়, we are about to end up, our string is about to finish processing, তখন কি করব আমরা ওটাকে এই পার্টিকুলার ট্রানজিশন ফাংশন দিয়ে রিপ্রেজেন্ট করব। মানে এই দুটো রুল তোমাকে মনে রাখতে হবে। Is it clear? The rules are clear, somewhat clear. I'm not saying 100% but somewhat clear, because once we do apply it in a particular problem then it will be 100% clear. So these two rules will be employed while we are creating a PDA corresponding to a given context-free grammar. In the context-free grammar, we have 4 tuples, capital V, sigma, S. So these three are not so significant. I've always told you. 2 parts are most important for us. One is capital P, one is delta. Capital P is a part of CFG, delta is a part of M, PDA, machine. So where will the mapping come? So these, जहाँ पे ये productions होगा, कैपिटल A gives V, ये तो कैपिटल P में होना चाहिए ग्रामर में, उसकी जगह पे मुझे ऐसा रिप्रेजेंट करना पड़ेगा, because PDA is represented by 3 parameters and using transition functions delta. So हर एक प्रोडक्शन इस सेट के लिए ऐसा रिप्रेजेंटेशन होगा, हर एक प्रोडक्शन जहाँ पे सपोज कैपिटल A gives स्मॉल a हो रहा है, वहां पे इस तरह का हो जाएगा, यहाँ पे टर्मिनल में खत्म हो रहा है, वहां पे इस तरह का हो जाएगा। Let's see, I think there's a question. Suppose we have a grammar. So first one is what? Capital V. So capital V has S, A and B as 3 non-terminals. Sigma has 0 and 1, capital P and S. S is starting sentential form, where capital P is given as S gives 0B or 1A, A gives 0S or 1AA or 0, and B gives 1S or 0BB or 1. Okay, so that the string, it will be show that, not so that, show that the string 000110110, this is a given string, it belongs to the context-free language L of G. We have to show this one first, and next we have to design a PDA corresponding to this given grammar and show it so that it is accepted by the machine. So this is a long process. Okay, it is a lengthy process where we have to first show that it belongs to CFG. Second, we have to design its corresponding PDA, and then we have also to show that it is accepted by machine. And acceptance can be done in two ways, either by null store or final state. Here we will be using the null store concept. So see, so suppose we will begin with S gives 0B. Then we are using this, so this B will be converted into 0BB. So it becomes 00BB. Next, so we are basically using the left recursion, isn't it? Left derivation we are using. Are we using the left derivation?
Yes, sir.
This is just the normal parsing process. If you remember the parsing process of context-free grammar, in the end, our objective is to find out 00011011110 by applying all these productions and deriving the setup or the sequence. Then at the end, we should have this. So we are getting it. I think this part I think you can do. Do I need to specify further? I think you'll be able to do it. We are just substituting different productions so that the end string can be achieved or derived. Do I need to specify it or you will be able to do it? बोलो किसी को दिक्कत हो रहा है तो बोलो तो कम से कम मुझे कैसे पता चलेगा दिक्कत हो रहा है Tell me. Anybody is finding difficulty somewhere? You need to tell na. Madhu mai? Are you there? Madhu? কিছু বলছো না আজকে কোনো ডাউট হচ্ছে বুঝতে পারছো না ওকে আর কে আছে প্রিয়ব্রত প্রিয়ব্রত is not there প্রিয়ব্রত ছিল তো হ্যাঁ প্রিয়ব্রত আছে তো হ্যাঁ আচ্ছা প্রিয়ব্রত তো এই অন করছে কিছু আনমিউট করলো বুঝতে পারছো প্রিয়ব্রত একটু প্রবলেম হচ্ছে রাহুল समझ में आ रहा है
यस सर
पक्का
समझ रहे
एग्जाम ले ले सरप्राइज टेस्ट 2020 का आखिरी टेस्ट
कल ले लीजिएगा सर
अच्छा और जो लोग एक्टिव रहते हैं क्योंकि मैं सबका नाम ले सकता हूँ और बताओ नवाज
सर वो इधर सरप्राइज टेस्ट मत लीजिए
नहीं टेस्ट नहीं होगा नहीं लेकिन समझ में आ रहा है
ऑनेस्टली बोले तो लाइक पहले कुछ क्लासेस मेरा मिस गया था तो अभी
आज जो पढ़ा रहा हूँ आज जो पढ़ाया वो थोड़ा आ रहा है
हाँ
नहीं जो जैसे आज तो पीडीए नया पढ़ाया तो पीडीए तो एकदम न्यू टॉपिक था उसमें नहीं समझ में आया क्या था बताओ
नहीं सर ये ठीक है लेकिन पहले का वही बोल रहे थे
हाँ पहले का थोड़ा सा बुक से पढ़ना पड़ेगा प्लीज बुक से पढ़िए और नोट्स मिला हैव यू मैनेज नोट्स फ्रॉम योर सीनियर्स आप लोग को नोट्स मिला क्या अच्छा अनामिका
यस सर
বুঝতে পারছো
হ্যাঁ বুঝতে পারছি কোথাও কোথাও ডাউট হচ্ছে
তো সে জিজ্ঞেস করবে তো সঙ্গে সঙ্গে জিজ্ঞেস করবে যদি খুব বড় মেজর ডাউট হচ্ছে তাহলে তো জিজ্ঞেস করতেই হবে আর মাইনর থাকলে মনে হচ্ছে কি একটু পরে ম্যানেজ করে নেবো দ্যাটস আ সেপারেট থিং ডাউট জিজ্ঞেস করতে হবে হ্যাঁ মানে আমার তো মনে হচ্ছে আমি পড়াচ্ছি কেউ ডাউট জিজ্ঞেস করছে না মানে এভরিথিং ইজ ফাইন আই এম ফিলিং দ্যাট ওয়ে Okay, so if you have a doubt, kindly unmute and ask. Okay?
ঠিক আছে স্যার হ্যাঁ ওকে স্যার
আচ্ছা দীপান্বেশ শুনছে কথাটা আমাদের দীপান্বেশ দাস দীপান্বেশ কিছু বলছে না Great, okay, let's continue. So this is a part of just the normal derivation where we are substituting various productions so that the given string can be created or derived. Do you want me to show this one once? You need to specify because Abhidha, because just believe me, I cannot daydream, na. You need to specify. It is your requirement. You need to tell, na. Sir, explain please. Otherwise, I will be feeling कि यार बहुत अच्छा पढ़ा रहा हूँ मैं. I have taught you all, which will be wrong. Otherwise, okay. Let's see. Suppose these productions are given to us. So we have to derive a string. So I'm beginning from S gives AB. S gives 0, 0B. Then what are we doing? Generally we use the symbol, this symbol we use, implies symbol. So next it implies what? And we are using underline to indicate which production we are substituting. So 0B. So instead of 0B, we will write 0 and 0, we write 0, 0, BB, right? 0, 0, BB. So which production we are applying over here? Since B gives 0 BB. This production we are applying. B gives 0 BB. Is this clear? This part is clear though. Instead of this B, we are writing 0 BB. Next, this B. What will we do? What will we do? Same thing. So 0, 0, 0, BB. This one, do same thing. Next up, why are we doing this one? Why are we doing this 0, 0, 0? Because you can see in this string we have initial first 3 zeros. Now 1 is coming. So for that one we have to apply B gives 1. So we'll be having 0, 0, 0, 1B. 1S. Achha, I think we have done mistake somewhere. It will be 0, triple B, na? Triple B, so. We had 0, 0, BB. Instead of this B, we'll be writing 0, BB. So now it will be triple B. It will be 1, BB. Why am I not doing 1S? You're saying 1S. Let's see. দেখছি আমি এটা কনসিডার করছি এইটা স্ট্রিংটা 00011011110 এইগুলো বি গিভস 1 করতে পারি না হ্যাঁ বি গিভস 1টা করছি ঠিক আছে না আমি 1s টা করলে কি হবে না তারপরে আবার 1s এর জায়গা 1a 0b আসবে সেটা দেখছি যদি এটা না হয় তাহলে আমরা করবই সো হিয়ার উই আর অ্যাপ্লাইং b gives 1 here we are applying b gives 1 okay next up এরপরে কি করছি আবার একটা 1 করছি তো 0 0 0 1 1 b this is same repeated okay এরপরে 0 0 0 1 1 তো আছেই আর আবার 0 bb good 0 bb এরপরে আবার 1 ঠিক আছে না আবার 1 দিয়ে রিপ্লেস করলে কি আসবে 0 0 0 1 1 0 1 b আবার কি দেখতে পাচ্ছি আমরা কি বাকি আছে আবার না আবার এখন b এর জায়গা করব 1s তাহলে কি আসবে তাহলে বেসিক্যালি আসছে 0 0 0 1 1 0 1 1s instead of b I'm writing 1s ঠিক আছে এরপরে s এর জায়গায় 1a লিখছি s এর জায়গায় 1a 1a আর লাস্ট a এর জায়গায় 0 so we have 0 0 0 1 1 0 1 1 1 1 0 তো এটাই ম্যাচ করছে ইনপুট স্ট্রিং এর সঙ্গে 0 0 0 1 1 0 1 1 1 0 ট্রিপল 1 0 দেখো লাস্টে
স্যার ওখানে একটা এক্সট্রা 1 পড়ে গেছে মনে হয় ওই জায়গাটাতে ওই সেকেন্ড লাইন এখানে আমরা তো এস এর জায়গা 1 এ পুট করছিলাম না এটাই তো হ্যাঁ এটার জন্য হয়েছে বলে এখানেও হয়ে গেছে ঠিক আছে এখন সবাই বুঝতে পেরেছে আমি জানি না কতজন বুঝতে পেরেছে বাট what else can we do this is the most optimum that I can offer right now আমি এটা আর ডেরাইভ আর কি করতে পারি বলো at least এই পার্টটা ফার্স্ট পার্টটা where we have to show that this particular string belongs to the context-free grammar. For showing, we have two approaches. One is derivation approach, যেখানে আমরা ইউজ করেছি leftmost derivation, মানে লেফট গুলোকে বার করে করে আমরা ডিরাইভ করছিলাম, আর আমরা রাইট মোস্টও করতে পারি, ঠিক আছে। আর একটা হয় যেখানে আমরা ওই ট্রি ফরম্যাটে করে টপ ডাউন ট্রি, বটম আপ ট্রি, এই দুটো ট্রি ফরম্যাটে করা যেতে পারে। আচ্ছা, এটা তো হলো ফার্স্ট পার্টটা। উই হ্যাভ শোন দ্যাট দিস ল্যাঙ্গুয়েজ, মানে দিস পার্টিকুলার স্ট্রিং বিলংস টু দ্য কনটেক্সট ফ্রি ল্যাঙ্গুয়েজ L of G. Now we have to design a PDA. So for designing a PDA, let us design the transition function first. So we have a set of production rules. We have to design the transition function based upon these two rules, rule 1 and rule 2. These two rules are used while we are trying to convert from the CFG to the corresponding PDA. Correct? So we have to check out first, A gives alpha, these kinds of productions. So for these productions, we will be forming, or we will be in representing using these sorts of transition function, where this this left hand side variable would be the part of the stack, as well as, and the alpha which is on the right side will be the part of the stack after the transition is complete. Let's see. So you can see using rule 1 we have, so can we say these particular functions are coming in? Suppose q0 epsilon s, S over is starting potential form. That's why S we have used. We have not used Z0. This can this be converted into Q0 0B? Q0 epsilon S, can it be converted into Q0 0B? Why are we doing it? Because S to 0B is one transition. This S gives 0B will become Q0 epsilon S gives Q0 0B. Is it clear? Is it clear? Next up, S gives 1A. So see, Q0 epsilon S will be 1A. See 1A. Next, suppose with A, let's see with A. So A will give 0S. So see over here, Q0 epsilon A will give Q0 0S. Again with A we have 1 double A. So Q0 epsilon A will give Q0 1 double A. Are you understanding what I'm saying? What I'm doing? A will give 0. So Q0 epsilon A will give Q0 0. Is this clear? Similarly, Q0 epsilon B will give 1S, Q0 epsilon B will give 0BB, and B will give 1. So you can see 1S, 0BB, 1. So basically you could see how many total transitions were there, total productions were there. 1, 2, 3, 4, 5, 6, 7, 8, and that many number of transitions we have. So those 8 productions are now transformed into 8 transitions of the corresponding PDA. Is it clear? Now,
Yes.
so that was all happening because of rule 1. Now rule 2 says that whenever we have terminal, this is not about the terminal, this is about the variables. Remember, these are all the non-terminals. So rule 1 was applicable for the non-terminal. But when we had the variables, like suppose if we had 0, 0, suppose input tape has 0 and stack symbol is also 0 on top of stack. So what will happen? It will be absorbed. I told you now. If we have terminals on both sides, on the input tape also, on the stack also, then it will be absorbed. Correct? Same thing we have done. So Q0 0 0, it will become Q0 epsilon, and Q0 1 1 will become Q0 epsilon. So these two transitions are also added. Are you understanding what I'm saying? This is based on rule 2. Rule 2 says that if there is a terminal both on the input tape also, on the stack also, in that scenario, after transition we'll be removing it. Basically, we'll be popping it out. So for popping out, we know the mechanism is Q0 epsilon. A state comma epsilon. It could be Qi. Let's say Qi comma epsilon. Okay. We are just representing the transition function. More than the state change, what is important is these are showing the mapping from the productions of the context-free grammar into the transition, that is delta, of the push-down automaton. After we have done that, we have to show that this particular string, the same string, is accepted by the machine. So we have got 10 different transitions. Now we have to again apply these transitions to derive or to show how this particular string is accepted using the null store method. That means the stack has to be empty in the end. So that you need to do. So you can just check. I'll just show the beginning. Suppose we have Q0 in the starting. the original string, and S is the starting sentential form. Okay, we are not using over here Z0 because Z0 is not a part of these transition functions. Since we are mapping from context-free grammar to PDA, that's why Z0 is nowhere there. Over here, Z0 is basically indicated by capital S only, starting sentential form. Once that is done, so first 0 is, see, 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0. This will be transformed into, what have I done? We have used the first transition. So first transition says what? What does my first transition say? That if this is the format, Q0 sigma, Q0 epsilon S, it will be transformed into Q0 0B. So the S, which was S initially, will now be 0B. So see, this S initial has now become 0B. Is it clear? Using T1. Next, now what do we have? We have Q0 0 0. We have Q0 0 0. So Q0 0 0 means this one, T9. Q0 0 0 is T9. So using T9, what will happen? This 0 will be, so these two zeros will be removed. So now one 0 will be lessened here, and that 0 will be popped out from the stack also. So now we have Q0. There were 3 zeros, now we have 2 zeros. 2 zeros and the remaining string, and now B over here. After this, we are applying T7. So if you have got the note, fine. If you have not got the note, at least write this particular state and these one, like T7, T9, T7, all these particular transitions that we are using. In the end, we should get the null store. That means the empty stack, which will show that the given string has been successfully accepted by the PDA. And this PDA we have generated or we have designed from the given context-free grammar. This question had multiple things to do. First, there's a grammar given to us, context-free grammar with 4 tuples, and a particular string has been given. We have to first see whether that particular string belongs to the grammar or not. That we had done using the left derivation process. That we had done. In the end, we are getting the complete string done. That means it is accepted. Second, we have to design a push-down automaton corresponding to this grammar. That we have to do by specifying the different transitions and showing what are the different 7 tuples. So capital Q will now become Q0, Q0, Q1. So all that state changes would, over here, your capital T is Q0 because we are not showing any state change. Showing a state change is not compulsory. While doing the correspondence between CFG and PDA, showing the state change is not compulsory. But what is important is showing the different transitions. S will give 0B, S will give 1A, because all these things are the part of the production rules. So that is done, and then we will show how the corresponding PDA that we have just generated, that we just designed, is used to show the acceptance of the string by the null store concept. So we will be showing how this entire string will be processed, and in the end our stack will be empty to indicate that the given string has been successfully accepted by PD. Clear? Am I making some sense? Or everything is nonsense? Sensible, no? So only for like you and Debarti and few more like Priyabhat and all, Nawaz and all, because only 5 or 6 people do interact with me. Except that everybody, I don't know, like, are you enjoying the winter weather? Weather is cool, but topic is not that easy. That I think you've understood by now. That you've understood from first week only, I presume. So you need to listen to me now. At least some kind of complexity can be lessened. I'm not saying our mission can be achieved fully through this online mode of communication, but at least to some extent, when you just once go through the book, then because of this lecture of mine, your understandability enhances, right? Na? It must happen though. That should be the core motto of this our lecture, online classes. Otherwise, what is the use of online classes? So you will be reading from the book, you will be having a concept on your own. Once you attend my lecture and then you again read the book, then the concept has to enhance, understandability has to enhance, isn't it? If there is no change in the process, that means whatever I'm teaching is all farce, it's all wrong, incorrect, or not up to the mark. But I don't know if you are paying really good heed to my communication, to what I'm saying. At least understandability has to increase if you go through the book. Let's see. Now this is just the opposite one. I'll just do this one and only this one let me do it quickly. So in the first part we had done conversion from CFG to PDA. Now we'll be doing the opposite. We have a PDA, we have to form, or we have to find out what will be the context-free grammar corresponding to it. That means from 7 tuple to 4 tuples we have to form. So for the given PDA, 7 tuples are mentioned. Accepting a language L by null store, the corresponding CFG G with 4 tuples V sigma PS can be generated as follows. So what are the rules? The first rule states the set of non-terminals V in G is constructed as follows. We have to compose capital V. So from where will we compose capital V? Capital V will be equal to S union Qi, Z, Qj, where Qi and Qj both belongs to capital Q for all Z belonging to gamma. Now Z we know is a part of gamma. Correct now? So we have to do the union operation with S so as to create the capital V at the end. This is the first rule. Second rule states the production for the starting symbol S are designed as follows. So S will be given by Q0, Z0, Q. So if we have these sorts of transitions, we can claim it to be capital S, where Q0 is the starting state of the read head, capital Z, then Z0 is the, what is Z0? Z0 is the initial symbol on the push down store, and Q belongs to capital Q. Rule 3 states, once we will do the numerical, then I think it will be more easier to understand. Rule 3 states a transition function involving the popping of a symbol, not copying, it will be popping out of a symbol from the push down store, such as, suppose we have Qj, Aj. Okay, suppose we have Qj. Suppose we had delta of Qj, A, capital Z. If this was the delta transition, it would generate Q. So these kinds of transitions will be leading me into production of this form. So Qj, Z, Q gives small a. Just see it properly, what I have done. Is it understandable? I am showing that a transition function involving the popping of a symbol from the push down store, such as, this is showing the popping symbol. Na? Suppose we are having Qj, we have A and Z. So this is on the input stack. This is on the input tape, not stack, tape. This is on tape. This is on stack. And this was giving me this kinds of transition. Q, SLN, a new state, and SLN means we have to remove, pop out. So this can be transformed into, see, Qj to Q stack original value will lead into terminal A. Is it understandable? Somewhat understandable?
Yes, sir.
Then one more rule we have, rule 4, which states that a transition function that does not involve the popping of a symbol, it will not be copying, it will be popping, pop out, P-O-P-P-I-N-G, popping of a symbol from the push down, may either keep the push down store as it is
or push a string of symbols as represented by the following transition function. So just see, if we had this kind of transitions, delta of qj comma aj gives q comma z1 z2 z till zn. It will lead me into production such as qj z comma qm will give me a q z1 q1 q1 z2 q2 q2 z3 q3 and so on, where q1 q2 q3 till qm is the possible set list of states for the PDA. Let us do a numerical and then we will understand I think better. Suppose for the following PDA M, design the corresponding CIG. So we have been given PDA. What we have to do? We have to find out V sigma PS of context-free grammar. So the corresponding context-free grammar can be constructed as follows. V is given by, what did I say? V should be given by sigma union what? All the productions of the form Qi comma Z comma Qj. So you can see Q0 Z0 Q0 Q0 Z0 Q1 Q0 Z0 Q2. So all these sets will be now the part of capital V. And from where have we got this? We have got it from here. See properly. From where have we got the capital V? Capital V we have got from the rule 1 which stated that here rule 1 said what? S union Qi comma Z comma Qj, where Qi and Qj belongs to capital Q for all Z that belongs to gamma. This is Z. For all Z that belongs to gamma, Qi and Qj that belongs to capital Q, we have to make a union and we'll go on adding until we get the full list of capital V. Okay. So full list of capital V is given as S, comma, Q0, Z0, Q0, Z0, Q0, Q0, Z0, Q1 and so on. By this one, we'll be having many number of elements of capital V. Now, S productions are given by, so how many productions are dealing with S from here? As you can see, how many productions are there that deals with S? 3. S gives Q0, Z0, Q0, Q0, Z0, Q1. Because we know that rule 2 states the production for the starting symbol S is designed as follows. It should have Q0, Z0, Q, where Q0 should be the starting state, Z0 should be the starting symbol on the stack. For every Q belongs to capital Q. So over here, every Q is what? It is Q0, Q1 and Q2. These are the 3 possible Qs. Q0, Z0 remains same. So Q0, Q1, Q2. Now these 3 will be productions based on S. And what are the productions corresponding to transitions? So these are the transitions given to us. Based on this, we have to find out for individual transitions, the set of productions. So look at this one. Suppose the first one, del of Q.
শোনা যাচ্ছে না স্যার।
comma a z0 है ना? আছে তো? So
স্যার ওগুলো শোনা গেল না।
Okay, fine. I'm saying कि a first transition, because of this first transition, what will be its corresponding productions? Okay, suppose we have delta of Q0 a z0 that was giving me Q0 a z0. So based on this transition, first transition, what we will be having? We'll be having a list of productions. So, see over here, Q0, Z0, Q0 will give A, Q0, A Q0 and Q0, Z0, Q0. This transition, Q0, Z0, Q0, Q0, Z0, Q0 will give A, Q0, A Q0, this is Q0, A Q0, comma, Q0, Z0, comma, Q0. Similarly, Q0, Z0, Q0 will give A, Q0, A Q1, Q1, Z0, Q0. This way we'll go till 12, for P4, P5 till P12. Are you understanding what I'm saying?
স্যার এর পরে এই দুটো কিভাবে এলো এটা বুঝতে পারছি না, মানে এইটা অবধি ক্লিয়ার আছে Q0 Z0 Q0 থেকে A, তারপর এই দুটো কিভাবে এলো এটা বুঝতে পারছি না।
For all the states,
Q0 হলো Q1 তাহলে Q2 করতে হবে for different states না সবকটা স্টেট নিতে হবে তো সবকটা স্টেট নিতে হবে Q0 নিয়েছিলাম Q1 নিতে হবে Q2 নিতে হবে এখানে Q0 ছিল Q1 ছিল Q2
ও আচ্ছা 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 ঠিক আছে ঠিক আছে
ঠিক আছে এটা যখন নিয়েছিলাম আমি Q0 Z0 Q0 নিয়েছিলাম এখানে তিনটে Q0 ছিল এখন তিনটে Q1 দিয়ে আসবে দেখতে পাচ্ছ তিনটে Q1 নিয়ে আসবে আর যখন Q1 নিয়ে আসবে আবার Q0 Q1 Q2 দেখছো Q0 Q1 Q2 আর আবার
যতগুলো পসিবল কম্বিনেশন হতে পারে সবগুলোই আসতে থাকবে
সবকটা এইটা খালি হলো ইমাজিন এইটা খালি হলো ফর দ্য ফার্স্ট ট্রানজিশন সিমিলারলি উই হ্যাভ 1 2 3 4 5 মোর ট্রানজিশনস তাদের জন্য করতে হবে এইভাবে সাপোজ সেকেন্ড ট্রানজিশন জন্য যেখানে ছিল Q0 AA will give Q0 AA এটা ছিল তো আবার ওখানে দেখো Q0 A Q0 will give A Q0 A Q1 A Q2 দেখতে পাচ্ছ এটা ছিল তিনটে Q0 জন্য Q0 Q1 Q2 তারপরে তিনটে Q1 এর জন্য Q0 Q1 Q2 তারপরে তিনটে Q2 এর জন্য Q0 Q1 Q2 Are you understanding what I'm saying?
Yes sir.
Similarly তোমাকে এগুলো সবকটার জন্য করতে হবে নেক্সট স্টেপ হচ্ছে তোমার কি আছে এটা Q0 CA will give Q1A Q0 CA will give Q1A এখান থেকে তোমার তিনটে আসবে আবার ওই Q0 Q1 Q2 করে C থাকবে বাইরে আর Q1 A Q0 A Q1 A Q2 তারপরে Q1 CA gives Q2 epsilon এটা এখান থেকে কি আসবে Q1 A Q2 gives A only A because that was the concept of rule number 3 rule 3 বলছিল তো মনে আছে rule 3 বলছিল যদি আমি এটা পপিং আউট করছি সিম্বলটা তখন কি হবে this is only dealing with symbols remember যখন আমি পপ আউট করছি সিম্বল তখন ওটা তো কি করবে ওটা জাস্ট ইমপ্লাইড A হয়ে যাবে এখানে দেখ রুল নাম্বার 3 দেখো look at rule number 3 a transition function including the popping out of symbol suppose Q1 AZ will give me Q epsilon so A থাকলে ইনপুট টেপে ওটা পপ আউট করে দেব it will lead me into QJ ZQ will give me A ওটাই করলাম এই দেখো Q2 A QZ will give me A দেখছো
yes sir দেখছি
আর লাস্ট স্টেপটা হচ্ছে ফর দিস ট্রানজিশন ডেল্টা এটা ঠিক করে দেখা যাচ্ছে না ইট মিন্স ফর Q2 epsilon Z0 থেকে Q2 epsilon এখান থেকে আসবে তোমার যেটা লাস্ট এটা Q2 Z0 Q2 will give me epsilon Q2 Z0 Q2 will give me epsilon তো এইভাবে তো তোমার কনটেক্সট গ্রামার থেকে পিডিএফ কোডটা স্টিল একটু ছোট easy to do because that we have done over here that we have done but উল্টো প্রসেসটা মানে যেখানে তোমার ট্রানজিশন দেওয়া আছে সেখান থেকে প্রোডাকশন ফর্ম করলে because you understand for each transition we have to take in a record all the states over here we are dealing with 3 states Q0 Q1 Q2 so সব কটা ট্রানজিশন জন্য তিনবার করে দেখো কম্বিনেশন অফ 3 each এই তিনটে Q0 তিনটে Q1 তিনটে Q2 জন্য কি ট্রানজিশন আসবে সব কটা আমাদের ধরতে হচ্ছে it's a lengthy process ঠিক আছে আজকে এত দূর next दिन we will start with deterministic PDA and deterministic C
স্যার এবার এই কোশ্চেনটা একবার একটু দেবেন
ওকে
স্যার এই কোশ্চেনটা একবার একটু দেবেন
রাইট দ্য কোশ্চেন
না এই কোশ্চেনটা একটু দিন না হ্যাঁ মানে যেটা করালেন ওইটাই
ওই টাইপের কি ওইটাই
ওটাও দিন ওই টাইপেরও দিন মানে একবার করে দেখবো বাড়িতে সেই জন্য এতগুলো স্টেট
হ্যাঁ ঠিক আছে এই নাও এই তো কোশ্চেন
আচ্ছা স্যার ঠিক আছে
হ্যাঁ একটা ফটো তুলে নাও এমনি মনে হয়
প্রিন্ট করে নিয়েছি
মধুময় মনে হয় ওটা নিচ্ছে মানে वीडियो করছে মধুময় रिकॉर्डिंग
यस सर कर रहा है
ठीक
डन सर
अच्छा anybody has got CK Nagpal till now anybody has bought or anybody has been able to download कोई है क्लास में CK Nagpal? No answer. Great. Okay, great.
স্যার আমার কাছে বইটা আছে।
এটা কে বললো? হু ইজ দিস?
আমি শ্রীময়ী।
আচ্ছা, শ্রীময়ের কাছে বইটা আছে, ভালো। তাহলে একটু পড়াশোনা করো, একটু বন্ধুদেরও হেল্প করো, যদি ওদের কিছু যদি কিছু ডাউট লাগে তাহলে একটু একটু না স্ক্যান করে ওদেরকে পাঠাও।
হ্যাঁ অবশ্যই অবশ্যই অবশ্যই। আচ্ছা
স্যার এটা কি নাগপালের বইটাতেই আছে?
হ্যাঁ, নাগপালের বইতে আছে এটা।
আচ্ছা আচ্ছা,
ঠিক আছে, ওখানে আর একটা এক্সাম্পল দেওয়া আছে এরপরে, সেটাও করতে পারবে তাহলে। ঠিক আছে, ওকে দেন আজকে তাহলে রাখি। ওকে, টেক কেয়ার, উইশ ইউ মানে in advance now, because we'll be wishing it next after 3-4 days. So have a safe last 2 days of your this old year 2020. Okay.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay, chalo. Bye.
bye sir.
Bye, sir. Happy New Year, sir. Advance. La 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 la.